Hello everyone, welcome to a video on solving absolute value equations. The goals of this video will be to solve absolute value equations, write absolute value equations, solve equations involving two absolute values, identify special solutions of absolute values, and solve absolute value equations using a TI calculator. So how do we spot an absolute value equation? An absolute value, designated by the two bar symbols, measures the distance a number is from zero. Then, since the absolute value measures distance, the absolute value of a number is always positive. So for example, if I take the absolute value of 5, that's going to equal 5 because the 5 is 5 units away from 0. However, if I take the absolute value of -5, it's also going to be 5 because if you think of the number line, the number -5 is also 5 units away from 0. Some of you might remember absolute values by saying that it makes anything that is inside the two bars positive. An absolute value equation will then be an equation that contains an absolute value expression. So what steps are we going to take to solve absolute value equations? Well, the first thing we have to do is we have to isolate the absolute value expression, then write two related linear equations, and then we're going to solve each linear equation as we've done in the past using inverse operations. And then, of course, we're going to check each solution. So let's start with some simple absolute value equations. 1a reads, the absolute value of x is equal to 7. Now, remember the example we did in the previous slide that said that if we have a positive 5 inside the absolute value of that positive 5 will be 5, but also the absolute value of a -5 will be 5. So that means for us that either x is equal to 7 or, just like this one, -x is equal to 7. So the first one, the equation is already solved. But for this one, I have that negative in front of the x, so we can divide by -1 both sides, and that means that x is equal to -7. So we have two solutions. Let me do a number line here. One solution is positive 7. 1, 2, 3, 4, 5, 6, 7. Right here, positive 7. And the other one is -7. So 1, 2, 3, 4, 5, 6, -7. You can also think of it like this. This equation says that the distance from x to 0 is 7 units. And if you count that, this would be 1, 2, 3, 4, 5, 6, 7 units from 0. But this -7 is also 1, 2, 3, 4, 5, 6, 7 units from 0. So then the solutions to this equation are x is equal to 7 or -7. What about 1b? Remember we said that the absolute value measures distance from 0, so the result of an absolute value has to be positive. However, this one is negative. This one reads that the distance from x to 0 is -7. That is not a true statement because distance is not negative. Distance has to be positive. So then this equation has no solution. So whenever an absolute value equals a negative number, that would be no solution. Let's try a few more examples. Okay, let's do 2a following the steps. First, we need to isolate. What exactly does that mean? Well, it means that there cannot be any number or values in front or at the end of the absolute value. Since there isn't any on this example, we are done with step 1. Now we need to write the two related equations. The first one will be that expression inside the absolute value, and we let it equal to 53. That's equation 1. And equation 2 is going to be, we take the opposite in sign or the negative of that expression, and we let it equal to 53. Now, where does this come from? From that example, remember that example with a 5? The absolute value of 5 is going to equal 5, this one right here, but the absolute value of negative 5, if we make that value inside the absolute value negative, that is also 5. So we have two different equations that will give us the same result, the positive and the negative. So we take the expression as is first, and then we take the opposite of that to give us the two solutions. Step 2 is complete. Now we need to solve each equation, so let's go solve it. Right here I have 5 plus 8x is equal to 53. We're going to move the 5 first. This is a positive 5. We're going to move it by subtracting. 5 minus 5 will be 0, 8x, and 53 minus 5 will be 48. We haven't completely solved for x. We need to divide by 8. Because these two are multiplying and the opposite of multiplication or the inverse of multiplication is division. 8 divided by 8 is 1, so this would just be x. And 48 divided by 8 is going to be 6. Let's move on to the second equation. We are going to distribute that negative, and this will give us minus 5 minus 8x is equal to 53. Just like on the previous one, let's move this 5, but this time it's a minus, so we're going to move it by adding 5 to both sides. 5 minus 5 once again is 0, but now we have a minus 8x is equal to 58. Last step, we're going to divide by the negative 8. So this is going to turn into a 1x or just x, and 58 divided by negative 8, that is negative 7.25. Let's check our solutions. Be careful, we are going to check our solutions in the original equation. Let's write it twice so we can also check the second solution. So for the first one, we're going to replace the x with a 6. And for the second, we're going to replace the x with a negative 7.5. Bring the rest of the equation. And let's check if this is 53. We're going to do the same thing here. For the first one, 8 times 6 is 48, plus 6 is 53, and the absolute value of 53 is 53. So this one checks out. And for the second, 8 times negative 7 I wrote a 5 instead of a 7.25. Let me correct that. Right here, that was the solution. So we try again. 8 times negative 7.25 is going to be negative 58. Plus 5 is going to be negative 53. But the absolute value of negative 53 is also 53. So then this one also checks out. That means that the solutions for 2a are going to be x is equal to 6 or negative 7.25. So you're going to notice that solving absolute value equations is the same as solving linear equations, but instead of just solving one equation, you're going to have to be solving two every single time, the positive one and the negative one. So for now on, checking the solutions is going to be left up to you. Let's try B. Step 1, let's see if the absolute value has been isolated, and it has because there's nothing in front or at the end of the absolute value. However, this time I cannot create my two related equations because this absolute value equals a negative. And we know that distance cannot be negative, which is what the absolute value measures, so then this 2b has no solution. So remember, every time you have an absolute value that has been isolated and it equals a negative number, then this equation will have no solution. At any time that you wish to do so, you can always pause the video, try them out on your own, and then come back to see if your work matches what is going to be in the video. So let's begin. In this case, the absolute value is not isolated because there is this addition of 5 outside of it. So in order for us to have an isolated absolute value, we're going to have to first move this 5. So this is a positive 5. I'm going to subtract 5 from both sides. 5 minus 5 goes to 0, and now we have the absolute value of x is equal to 3. Step 1 has been completed. Let me label this with a 1 so that we know that what we did here was step 1. Before we move on to step 2, we have to check. Now that the absolute value has been isolated, there's nothing in the front or at the end of the absolute value, we need to check if it equals a positive number. And it does. So because it equals to a positive number, we can move to step 2 to write the two related equations. The two equations are going to be, we leave the expression as is and equal it to 3. The other equation is going to be by taking the opposite of that expression and equivalent to 3. All right, we did step 2. Now let's solve it. Let's go to step 3. Let's solve each of the equations. Well, the first one has already been solved completely. There is nothing else for us to remove from the x. X is already on its own, so the first solution is 3. However, on this one, we do have that negative, so we're going to divide by -1 both sides to eliminate the negative, and that's going to give us a result of x is equal to -3. This right here, where we solve for x, is step 3. Step 4 is going to be left up to you to check that both solutions work, but right now I'm going to tell you that they do. So then the solution to this equation are going to be x is equal to 3 or -3. Now never assume that the answers are going to be the same. This is what I mean. Let me go back to example 1. On this example, we got that the solutions were 7 or -7. Notice how there are the same number, one positive, one negative. But then in example 2, notice how they weren't the same. The first solution was 6 and the second was -7.25. On this one, it just happened to be that the solutions were the same, one positive, one negative. Just remember again that it's not always going to be the case. Let's write 3b. Now you might be saying at this time, no, this equation is going to have no solution because it equals a negative number. But we cannot make that decision because right now the absolute value is not isolated. The absolute value is being multiplied by a -4. So don't make the decision right here. Make it once the absolute value has been isolated. So let's isolate the absolute value by dividing by -4 both sides, since the -4 is multiplying. So now this turns into 1. So that would be just the absolute value of x. And on the right side, look at what happens. -20 divided by -4 is 5. So at this point, when the absolute value has been isolated and the result is a positive number, we are able to determine if we can continue or if it has no solution. So because it's positive, we can continue to step 2 and write the two related equations. The first one will be where the expression stays as is and is equal to 5. And the second one, when we take the opposite of the expression and we let it equal to 5. Just like in 3a, the first one has already been solved for. We just need to take care of the second one by dividing by a -1. So if we divide both sides by -1 on the second equation, that disappears, leaving us with x is equal to -5. So then the solutions, which it will be up to you to check, are x is equal to 5 or -5. Yes, they are the same number, but opposite in sign. Do remember that even though it happened in both 3a and 3b, it's not necessarily always going to be the same number. So just be careful, okay? Let's try a few more. I'm going to do 4a, and then you're going to pause the video and try 4b. I know 4b looks like kind of a challenge, but I have faith in you. I think that you can solve 4b. Let's isolate the absolute value by moving this 5. Subtract 5 from both sides. 5 minus 5 is 0. And we get the absolute value of 2 plus 2b is equal to -1. Uh-oh. We are at that point when we need to make the decision if we should continue and write the two related equations or say that it has no solution. Well, I have an isolated absolute value equaling a negative number. So that means that this equation has no solution. Yeah, I know, maybe I chose to do the easy one and I left you one that doesn't look as easy as the first one. But again, try it out. I want to encourage you to pause the video, try 4b, and see how far you can get and then come back. All right, the absolute value this time has two numbers that we need to move to make sure that it's isolated or that there is nothing around it. One is multiplying and the other one is subtracting. Remember, we move anything that is being added or subtracted first before the multiplication. So we're going to move this +1. Okay, here we go. That goes to 0, and I end up with -5 absolute value of 7m plus 3 is equal to -50. We're not done. We still need to remove this multiplication by -5, and hopefully it will turn this one into a positive so that we can create the two equations. So let's divide both sides by -5. And this gets eliminated, leaving us with the absolute value of 7m plus 3 is equal to, look at that, -50 divided by -5 will be +10. So since the absolute value is now isolated and it equals a positive number, we are able to move on to step 2 and create the two equations. So the first one will be just the expression inside the absolute value as is, equal to 10. And the other equation will be the opposite of the inside of the absolute value is also equal to 10. Let's solve the first one. -3 minus 3. This goes to 0. So 7m is equal to 7. We divide both sides by 7 because this m is being multiplied by 7. And that comes out to a nice number 1. Our first solution is 1. We're not done. Remember, we have to solve the second equation. Let's distribute that negative. And this gives us -7m minus 3 is equal to 10. Now, at some point when you've probably done like 1,000 of these, you can probably skip this step and just write the opposite in sign of the expression and start down here. I prefer to write every step so that I don't make any mistakes. Let's move to 3. Add 3 this time because this is a minus. This leaves us with -7m. 3 minus 3 goes to 0. And on the right side, this is a 13. One more step. Let's divide by -7. Don't lose the negative. This is 1m or just m. And on the right side, I cannot divide 13 by 7 evenly, but you can change it to a decimal like I did on the previous example, but you can also leave it as a fraction as negative 13 over 7. So then the solutions to be m is equal to 1 or negative 13 over 7. Don't forget to check if both work. So now that we've done 4 examples of solving absolute value equations, let's write absolute value equations. Let's start by reading example 5. For a poetry contest, the minimum length of a poem is 16 lines. All right, I'm going to put it right here. The minimum is 16. The maximum length is 32 lines. Okay? The maximum, let me put it over here, that's going to be 32 lines. Write an absolute value equation that represents the minimum and maximum length. So remember that an absolute value measures distance. In this case, it's going to measure the length of a poem. So I'm going to let x equal the length of the poem. So notice how now our numbers are 16 and 32. The 0 is not between them, but we can find the middle to act like our pretend 0. So let's find the distance from 32 to 16. Well, that is 16. But I want the middle of that, so I'm going to divide it by 2, and that's going to be 8. Now, of course, you can see that 8 is not going to be the middle number. What 8 represents is the distance from 16 to that middle number, and 32 to that middle number is going to be 8. So then the middle value will be 24. So the distance from 16 and 32 to the middle number is 8. So 8 represents the distance. That's what the absolute value will equal to. So that means that the minimum and maximum length of the poem from the middle is going to be a distance of 8. So then the expression will be x minus 24. And we can read this as the distance from x to 24 is equal to 8. Where x, remember, represents the length of the poem. "24" is the middle between 16 and 32, and 8 is the distance to the middle, or the pretend 0. This is what they're asking us to do to find the equation. Okay, let's go to solving equations with 2 absolute values. Now, in the previous examples, we only had 1 absolute value to worry about, but now let's see what happens if we have 2. So, which of the 2 absolute values exactly has to be isolated in order for us to move to step 2? Either of them. You can either check that the first absolute value has been isolated or that the second absolute value has been isolated. In this case, there's no need to isolate because neither has anything outside the absolute value. So we can move to step 2 and write the 2 related equations. So now you might be asking, okay, so which one are we going to make positive or negative? Well, in this case, we select one of them to make positive and then negative. So I'm going to do the first expression. So the first equation is going to be x plus 8 is equal to 2x plus 1. And the second one, I'm going to make the first absolute value opposite. Now, could you have made the second one, the 2x plus 1, the plus minus? Definitely. And you will get the same result. So for the first one, we have variables on both sides. I'm going to move the 2x. You know, that is my preference, to move the right variables to the left side, but you can also move the ones on the left side to the right side. 1x minus 2x is negative 1x plus 8. 2 minus 2x will be 0 equal to 1. I'm going to move the minus 8 here. That goes to 0. So negative x is equal to negative 7. We're not done. We still need to remove that negative. So let's divide by negative 1. And the first solution is x is equal to 7. Let's write the second equation. Let's distribute the negative. So this will leave us with negative x minus 8 is equal to 2x plus 1. Move them 2x. Subtract from both sides. Negative x minus 2x, that's minus 3x minus 8 equals 2x minus 2x will be 0, and this will be 1. I'm going to move the 8. That's negative 3x. That goes to 0. Is equal to 9. One more step. We divide both by negative 3. 9 divided by negative 3 is negative 3. So the solutions to this equation are 7 or negative 3. So we have finished solving the equations. Don't forget to check your work. Let's go to 6b. Pause the video, try 6b, and then come back. Now in 6b, we have again two absolute values. Remember that step 1 is to isolate. On the previous ones, both absolute values were isolated. They didn't have anything in front or at the end of each of the absolute values. However, the one on the left has a 3 being multiplied, but the one on the right is isolated. So do we need to isolate both? No. As long as one of them is isolated, that will be okay. That means that this one, the one that is isolated, is the one that is going to create the two equations. This is the one that is going to take the plus and minus. So let's drop the absolute value from the left side. The first equation would be 3 times x minus 4 is equal to this expression as is. The other equation, the left side is not going to change. The right side will take the minus. So the one that was isolated is the one that takes the plus and the minus. So we had no need to isolate, and we have created the two equations. Now we need to solve. Let's distribute the 3. So this becomes 3x minus 12 is equal to 2x plus 5. Let's move the variables to one side. I'm going to move the 2x to the left side. Since I know I'm moving the variable to the left side, I'm going to move the minus 12 to the right side. Basically doing two steps at the same time. Variables to the left, numbers to the right. From left to right, that would be 3x minus 2x. That is just x. This goes to 0. Don't lose your equal sign. This is also 0. And 5 plus 12 will give us 17. And that is our first solution. Let's try it again with the second equation. On the left side, we have to distribute the 3. Don't forget that on the right side, we have to distribute that negative. Okay, so 3 times x will be 3x. 3 times negative 4 is negative 12. And the negative is just going to change the signs of 2x and 5. I'm going to do it again. I'm going to do two steps. I'm going to move the variables to the left side, while the constant gets moved to the right side. So 3x plus 2x is 5x. This is going to go to 0. Don't lose the equals. This one also goes to 0, and negative 5 plus 12 will be 7. Now, do we have to do two steps at the same time? No, you can do what we did in example 6 and move the variables first and then the constants. The only difference between the two is how much space it's going to take you on your paper to complete it. All right, we haven't finished this one. We still have this 5. Let's divide both sides by 5. This turns into 1x, or just x, and 7 over 5 cannot be divided evenly. You can change it to a decimal, but for now, I'm just going to leave it as a fraction. You can also change it to a mixed fraction if you choose to do so, but for me, this is enough. So then the solutions for 6b are going to be 17 or 7/5. Now, I know that you have been checking your solutions to make sure that they work. Why is it important to check the solutions? Because sometimes the solutions don't work. For example, this example 7. When the solutions don't work, that means that you have to reject one of them or both of them because they don't satisfy the original equation. Those solutions, the solutions that don't work, they're called extraneous solutions. Let's try this one. We only have one absolute value. It is already isolated. There's nothing in the front or the back. So we can create our two equations. I'm going to start writing them over here because I'm going to need all of that space. So the two equations will be, we take the expression inside the absolute value as is, let it equal to 2x. The second equation, we take the opposite of what is inside the absolute value, and we also let it equal to 2x. Let's try the first one. This time, I'm going to move the x's to the right side just to show you again that it doesn't matter in what direction you decide to move your variables, you can still arrive at a solution. So if I move this x to the right side, this is a positive x, so we're going to subtract both sides. X minus x will be 0. We left with a 6. Don't lose the equal sign, and 2x minus x is just x. And here's our first solution. Let's find the solution for this second equation. Let's distribute the negative. This is going to give us negative x minus 6 is equal to 2x. I'm going to move the variable to the right side by adding, since this is a minus. This goes to 0. Negative 6 is equal to 3x. We still need one more step on this one. I need to divide by 3 both sides. Divided by 3, divided by 3. Negative 6 divided by 3, that's negative 2 equals 2x. All right, so our two possible solutions right now are 6 and negative 6. Let's go back to the step and make sure that we did all of them. We did need to isolate because there was nothing in front or at the end of the absolute value. We created and we solved our two equations. Now we need to check our solutions. So I'm going to check over here. Remember, we checked with the original equation, not these two that we created and solved. So I'm going to bring this equation twice so I can check both solutions. So the first one that we're going to check is the 6. Wherever there is an x, I'm going to place a 6. And here's another one. So that's another 6. Let's bring the rest of this. So this is the absolute value plus 6 and 2. Let's do the inside of the absolute value. 6 plus 6 is 12. And the absolute value of 12 is just 12. On the right side, 2 times 6 is also 12. So then the 6 works out. This is a solution. Perfect. Let's try the negative 2. Right here, we're going to replace it or substitute with a negative 2. Bring down the rest of the equation to check. Here we go. Negative 2 plus 6, that is going to be 4. And the absolute value of 4 is 4. Perfect. But look at what happens on the right side. 2 times negative 2 is going to be negative 4. Now, even though they seem like the same number, this is a positive 4 and this is a negative 4. These are not the same. This is a false statement. That means that even though this equation gave us negative 2 as a possible solution, it doesn't actually work if we check it against the original equation. So then what is the solution to this equation? Only the 6. That's the only one that works. So this is the solution. What is negative 2 called? Negative 2 is called an extraneous solution. Remember, an extraneous solution is not the solution to the equation. It was an apparent solution that was rejected because it did not satisfy the original equation. So if they ask for the solution, 6 is the solution. The negative 2 was a solution that was rejected. Alrighty then, let's go to the last example for this video. And that is on how to solve with a TI calculator. Let me bring my calculator. If you watched the video on solving linear equations with variables on both sides, you probably remember how we did these, and it's going to be very similar, but we're going to add one more step. So here we go. We have to make sure that we change these m's to x's. So this is going to turn into negative 5, the absolute value of 7x plus 3 minus 1 is equal to negative 51. We go to y1, here's a y, and we enter the left side just the way it looks. Now, this is a negative 5 and this is a minus 1. So this negative 5 is going to be this button right here. So negative 5. And now we need to find the absolute value. So if you go to math and move to NUM or the numbers, you're going to see that it reads ABS, and that stands for absolute value. So press enter. There it is. Now we have the two bars waiting for us to write the expression inside of it. In this case, it's 7x plus 3. Here's the x plus 3. Now we get out of the absolute value and we enter the minus 1. Now you might be asking, how do I know if I'm supposed to put a minus or a negative? If it's at the start of the expression, that's the negative. If it's in the middle of the expression, that's a minus. All right, let's go down or press enter to go to y2. Now this is the beginning of the right side expression, so this is a negative 51, not a minus 51. So negative 51. All right, so we've done step 1, change to x's our variables. We've done y1, y2. Now we need to graph it. Let's see what we find. Let's go back to y1 for a second. The blue one is the left side. The red one is the right side, but I only see blue here. That means that I'm going to have to zoom out to be able to see where the graphs meet. So we're going to go zoom, and we are going to zoom out. That's 3. Press enter. I still don't see it. What else can I do instead of just zooming out? Change the window of my graph. So let's go to window. Let's see. I'm going to change this to negative 10 on the left side for the x's, positive 10 on the right side for the x's. Let me go to the y's. This y2 needs to be negative 51. So I need the y's, the negatives, to be lower than negative 51. So I'm going to make it negative 60. And this one can go back to 10. With practice, you're going to get really good at deciding what window we want. Let's go back to the graph. Now I can see both. I can see the left side, that's the blue one, and the right side, that's the red one. Perfect. Now we go to second, calculate, intersect, and press enter. All right, so second is the blue. Calculate is up here in blue for this key, so let's press that. So intersect is number 5. Let me go down to that and press enter. Okay, so it's asking me here, is this your first equation? This one right here in blue, and I go and I check the left side, and it is. But you notice how the cursor in the calculator is all the way over here? I want to know this intersection. So I'm going to move to the right until I'm close enough to the intersection that I want. I don't have to be exactly where they meet, but I have to be close to it. And I'm going to press enter. They're asking me if this is my second curve, and that's negative 51, and that is true. So I press a second time, and they're asking me, do you want me to guess? And you're like, yes, give me the answer. Press enter a third time, and we get a 1. So let's write it over here. The first solution is x is equal to 1. But remember that this equation, if you go back to your notes, because this is example 4b, this equation had 2 solutions, so I still have to go find the solutions. So that's why we have this step 8. I have to repeat 5 and 6 so that I can find my second intersection. So let's go back to 5. We're going to press second, calculate, down to intersect, and press enter, but I don't want this solution. I already have the solution. I'm going to move to the left. I'm going to move my cursor to the left so that I am close to the other solution. That's close enough. Press enter once, press enter twice, press enter 3 times. And this one reads that the solution is negative 1.8571. Okay. I'm just going to do negative 1.86. So negative 1.86. Don't forget, when you give your solutions, that the original equation had m's. We changed them to x's so that we could place this in the calculator. But we need to give the answer with m's because that is the original variable for the equation. So then this is m equals to 1 and negative 1.86. Now you might be asking, I'm checking my notes and we didn't get negative 1.86. We actually left it as negative 13 divided by 7. How do I know if that is the same answer? Well, you can get out of the graph. Let's do second mode to quit the graph. And then enter the negative 13 divided by 7. And you're going to get the same answer if you round, right? That's negative 1.86. Perfect. Now you know how to solve absolute value equations using a calculator. Before we end this video, there is a slide in your student notebook and it has a summary and it says the following. Remember, if the absolute value equals a number less than 0, that's a negative, you're going to have no solutions. If your number is greater than 0, you're going to have 2 solutions. But if you have a 0, it's going to have 1 solution. It also gives you a summary of what to do if you have 2 absolute values in your equation. We still break it down into 2 equations. One will be positive and the other one will be negative. And remember that it is very important to check your solutions because sometimes those solutions don't work. Sometimes those solutions are extraneous solutions. As always, it is now your turn. I'm going to leave these 3 examples for you to try them out. You need to try them out on your own. Maybe now that you know how to solve them with a TIA calculator, you can also check your work with a TIA calculator. Thank you so much for watching, and I'll see you in the next one.